Hi, my name is Nwatu Amira Chinaza, and I'll be discussing exhaustively on adenosine receptors. When you hear adenosine receptors, what comes to your mind? Adenosine receptors are subclasses of gene protein coupled receptors, and gene protein coupled receptors are classes of protein that has the ability to bind with GTP known as guanine triphosphate in active states, or guanine diphosphate, which is GDP, in inactive state. Adenosine receptors are produced primarily in metabolism of ATP energy, which is known as energy, and it is found mostly in all parts of our body, but most abundantly in the CNS, central nervous system, which is the cortex. There are 4 types of adenosine receptors, and 1 is A1, 2 is A2A, 3 is A2B, and the 4th one is A3. But before I go into the definition of that, I would like to take you through the processes of how a gene protein, how the gene protein runs. When a receptor, or when an hormone is water soluble, in the sense that it cannot diffuse through the phospholipid area, so the whole binding of the receptor and the ligand must be at the cell surface receptor, and the process of this, a second messenger or a middleman is introduced, which is known as the gene. The diagram above explains the pathway and the mechanism of adenosine. And firstly, like I said earlier, adenosine receptors are water soluble. They can't enter the cell, they can't enter the phospholipid. Due to their water soluble, they can't diffuse. So the receptor inside now move to the cell surfaces, where there will be binding of the ligand and the receptor. The adenosine binds with the receptor, which is coupled with the inhibitory gene A1 outside the cell surface, which inactivates the inhibitory gene protein, which in turn inactivates the adenyl cyclase activity. Like I said before, the A1, it inhibits the formation. Adenosine receptors are of great importance in our human body, in which when there is a lack, or when it is